We're going to get started. Welcome everyone to Wireless Power and Energy. We're energy harvesting, brought to you by the Wireless Communications Alliance. We're very excited about today's event. As many of you know who've been longtime WCA members, we like to have these events, especially on wireless power, because wireless power and wireless communications over some period of time are going to merge, right? You can't really have effective wireless power without a way to control and get analytics from the wireless power system. So we're really excited to have the opportunity to host this. We have a packed panel today. Many of you are expecting to see Doug from Ossia, and you will notice Doug is not here. Doug has no voice today. And so Jen Grenz, the CRO of Ossia, will be taking his place and doing a very able job replacing him because she has a voice. Today's panel, we're going to run the spectrum of how people are deploying wireless power and inventing technology in that space. We've got leaders from all across the market. So we will get to the speakers now, and let me walk through who they are. Speaking first will be Cesar Johnston, CEO of Energous, followed by Jen Grenz, the CRO of Ossia. Then she'll be followed by Charlie Green, the COO and CTO of Powercast. And then following them will be Jeff Yen, the founder and CEO of ETI. And then we'll hear a perspective from an analyst, Dinesh Kathani from WAWT. And me, I'm your host, Tom Hunt. I'm always your host, and happy to be here. Some housekeeping rules. Should you have questions, if you go into the Q&A section, you'll see the Q&A button on the bottom. Simply enter a Q&A. I'll be monitoring that and answering the panelists. We will try to have questions after each panelist, but we will certainly have questions at the end. And so let's get started with Cesar Johnston from Energous. If there's anybody who has the name wireless in their name, it should be Cesar. Cesar's worked at places like Broadcom and Marvell before being the VP of engineering and now CEO of Energous. He's worked in Wi-Fi, Bluetooth, FM, wireless power, NFC, and all of the traditional 802.11g and etc. So it's really a pleasure to have Cesar with us. And Cesar, I'm going to turn it over to you. You can share your screen and take it away.
Thank you, Tom. Great to see everyone here. Hello to everyone. And it's a pleasure to be here. Good afternoon. Let me get the slide here. Can you guys see the slides?
We can.
Well, great. And I'm going to try to blow it up. That's even better, right? So,
yes, sir.
Once more, thank you very much. It's a pleasure to talk about energy. Most important, talk about wireless, as Tom pointed out. It's been a passion of mine for a long time. I was there early in the days of Wi-Fi, Bluetooth, and we are all here now in the early days of wireless power and energy harvesting. And let's talk and agree on what energy harvesting means, because it means different things to different people. So having said that, before I start giving you some background of technology and our views here at Energous, let me tell you a little bit about Energous and the company. We are a fabless semiconductor company that has a very, very strong background on systems. We are focused primarily today on power at a distance. We see that as a tremendous value, a tremendous differentiator. And we see power at a distance for IoT applications. The markets are huge, and I will discuss that. But they have to start somewhere, as in the early days, Wi-Fi started. And as they grow and you increase your powers and you increase your distance, you will cover more and more markets. And we'll cover those markets. We are the leaders on regulatory approval. When we started the company 8 years ago, you could barely go beyond 0.5 millimeter using part 18. Certainly, you can claim that you can go at distance part 15. That was done by the communications guys, not by the power guys. So today we have part 18 out there, and we can go beyond half a millimeter to eventually 1 meter and unlimited distance. So wireless power is here, and wireless power will continue to be here and will increase from now on. As a company, we have over 200 patents. We are publicly traded in NASDAQ. Our symbol is WATT, and we are in Silicon Valley, San Jose, and we have over 50 employees. That's really Energous at a glance. Now, as I said before, and Tom has also mentioned, these are very, very exciting times. We are seeing the convergence of markets. We're seeing the convergence of wireless power and regulatory happening today. We are at an inflection point, and all we see from now on is just growth. And we see the future really bright. And again, we have to start, and I'm glad to see all these companies together today, because together we're going to make this happen. And when I say convergence, what I mean is the following, that the next generation IoT networks need power. IoT devices that are pretty much confined to cables and batteries is no way to go, and it's not the future. We have to remove those batteries, we have to remove those cables, and we can do that by deploying RF wireless networks. And that's our goal. We're going to remove all those trillions and billions of batteries out there, or we're going to make them smaller if possible. Now, having said that, the convergence comes in three ways. Number one, we have technologies. The technologies for RF wireless power have been developed. And by the way, they're not wireless communication technologies. We developed those over 30 years ago, and we know how to do that. We know how to build communication devices, but using communication devices for wireless power is not the way to go. So the idea is that the technologies today, and there are devices that are specifically designed for wireless power, they typically have higher efficiency than communication systems. Number one. Number two, we're seeing regulatory happening. In our particular case at Energous, we have unlimited power delivery of up to 1 watt conducted power transmitters in the US, in Canada, in Europe, and recently we announced China, and definitely we have India today. So what you're seeing now is you have the technology, we have the certification, and it happens that this technology and this certification are now crossing IoT markets that have been discussed for the past 18 years. IoT is an old word. IoT goes back to 18 years ago. But today it is very clear that it is possible to merge these three, and this opens up opportunities, and we'll talk more about that in my next few slides. At Energous, what we have is we have our WhatsApp solutions. As I mentioned before, there are dedicated devices, multiple devices that can be used to build transmitters and receivers. They're not communication devices. They're specifically designed for wireless power. They're all scalable. They're all low cost. They use the standard CMOS technologies and GaN technologies, the same way we've used in the past for communications. And the beauty of this is that eventually, as Tom pointed out, communications and power comes together. And they come together in the form of what we call here at Energous power bridges. And on the right-hand side, what you have is you have 1 watt conducted power bridges, you have 5 watt conducted power bridges, and then 10 watt conducted power bridges, 1 watt conducted power bridges with unlimited unlimited distance, and 5 watt and 10 watt up to 1 meter today. And as we move forward, the whole goal here of moving the technology is to push the power and to increase the power. And that's where the roadmap is, as all the companies that are sitting out here, I'm sure agree with. And then we design also receivers in the form of small devices that are specifically high efficiency rectification that use CMOS or gas technology. And those can go all the way up to 4 watts of received power. So the technology is here, the systems are here, the transmitters, the receivers are here. So what's next? So what the future is pretty bright, and the way we see it is that IoT devices are out there. So the moment you remove those batteries and you go to the lower part of these slides, what you see is you have devices such as tracking devices, sensing devices that get power. They get power over the air, and they get power with bridge mesh networks. In this particular case, power bridges, and those power bridges can be 1 watt. Those power bridges can be 5 watts. And in our particular case, we've worked on beamforming as well as non-beamforming technologies, and we do see some advantages in using our technologies in using beamforming solutions, which actually are cost effective today, as I mentioned, and we can go up to the 10 watts transmitters. And by the way, we're not limited by the technology. We can build large amounts of transmission power, but we're limited by certification, right? And what you do is you take those power bridges, those mesh network components that allow you to power those devices and also close the loop through an out-of-band communication channel, in this case, BLE. And by doing that, you can concentrate that data and then send the data to an access point to the cloud. So effectively, what you have is a vertical solution all the way from the cloud down to the sensors. And in our particular case, we have a number of partners that we have publicly announced. We work with companies such as Juniper, who is a leader on Wi-Fi and also Bluetooth. And we access the wireless infrastructure that way, all the way to the cloud. We have partners on the label. So in our particular case, we have focused our company today into two applications, RF tags and then electronic shelf labels. On the RF tags, we have companies and partners such as Wiliot or Atmosic. Those are extreme low power BLE or extreme low power tags that are competitive with, let's say, technologies like RFID. We have companies like ePeace and E-Ink that are companies that allow you to build together electronic shelf labels, and E-Ink is the leader on extreme low power display devices. And we have companies like Syntian, which now adds tremendous value to what we're trying to solve here, which means that today we're going to go and deploy and replace those batteries, and we're going to operate all those sensors. But because now we have power bridges and we have transmitters that are cost effective, that can be pretty much deployed like Wi-Fi, what you can do now is you can effectively add more processing right at the edge. And at the edge, we're talking about the edge IoT devices that now become smarter because we have artificial intelligence devices. And of course, your bridges can also become much smarter because they can concentrate the data, they can pre-process the data, they can minimize the data into the access point and get that into the cloud, and people can monetize. So we see a very bright future of this type of deployment moving forward. Having said that, where are we? We have RF tags, we have ESL, and you guys can just go and wonder. We're talking about a tremendous amount of devices that are going to be deployed out there. Today, we're talking around 12 billion devices and growing into 40 billion devices by 2025. And I'm not just pulling this number out of my hat. This is a number that comes from IDC. So it's a well-respected market researcher out there. And I'm just telling you 4 markets where we are focusing today. We're looking at industrial IoT, we're looking at retail, we're looking at healthcare, we're looking at a smart office. And altogether, these markets are in the order of about $300 billion that can be penetrated. And now, how do you use the solutions that we have? You go deploy your power bridges in the ceiling, on the walls, right? As you have all these markets, and then you can deploy your sensors, you can deploy your tags, you can deploy your ESL, and effectively support your smart office, your smart home, where maybe you want to be able to know if people are present or not, or whether the air quality is good, or you can be in an industrial site tracking your warehouse and seeing where your production devices are, being in retail and making retail pretty bright and smart today. And in healthcare, there's a big problem today. It's hard to find equipment, and being able to actually track that equipment and being able to get that into the emergency room, it's pretty tough. It takes about 2-3 hours for a nurse to find. And today, we can do that with this technology. And that's pretty much it. Thank you.
Cesar, thank you. If you could stop sharing, that'd be great.
Sure. There you are.
A quick question for you. So as we look at people in wireless power, our audience is always interested in spectrum and where you fit and what challenges you have related to what bandwidth does your technology work in, any issues with interoperability with Wi-Fi and other systems and interference? The traditional questions you've heard forever, right? So.
Definitely, and that's a matter of religion for some people. Uh, so our view is that 900 megahertz is the right solution and the right frequency for wireless power networks from many different perspectives. And just to be brief, from a technical perspective, having done Wi-Fi, having done Bluetooth, and having been a member of the Wi-Fi Alliance and knowing all my buddies out there, I can tell you that when we did Bluetooth and Wi-Fi, they wanted to have interoperability, and we actually had to sacrifice bandwidth. And I'm sure that if you go deploy at 2.4 and 5, they're going to come and they're going to hit us hard in the head, and they're going to go interoperate and have interoperability, and then we're going to reduce the amount of time that we can send charging on. So it is better to get away from them, in our opinion, and go to 900. Also, from a technical point of view, there is a specific absorption rate, which is a key factor to be able to actually pass certification. And as you go up in frequencies, the SAR gets worse. So at 900 megahertz, they are pretty manageable. And in the case of, as an example, our 10-watt transmitters, we're talking about levels of SAR that are almost half the value that you can actually have on your cell phones today. So it's important to pick the right frequency and operate in the right bandwidth. And as far as the bandwidth and the allocation, 2.4 is already overused. 5 is getting very crowded. Wi-Fi has moved to 6 gigahertz and is going to get crowded in the next 2-3 years. 900 is still kind of open. But the good news about wireless power is that we use very narrow signals, and that allows us to have multiple low megahertz kind of bandwidth solutions.
Well, thank you for that answer. One other question. You talked about unlimited distance for 1 watt.
Sure.
Can you explain?
Of course. Yeah. So when it comes to unlimited distance, of course, the signals go so far, and they're going to basically die at some point in time, but they're going to be so low level that the amount of power that you get is really negligible, right? So once you're going, let's say, as an example, beyond minus 30 dBm, you might actually not have a usable type of solution, especially for some levels of IoT. So when we say unlimited in the case of Energous is in a type of deployment similar to Wi-Fi, where you have your transmitters that can cover, let's say, up to 15 meters or more. And now you are deploying those every 15 meters. Is similar to Wi-Fi. And the moment you do that, you're unlimited within the boundaries of the deployment. And today, Wi-Fi is really unlimited by those terms.
Okay, perfect. And one last question that came from the audience. You basically answered it, but I just want to pose it a different way. What's the max distance you're seeing that you can power RF power a charging device? So
that's always
charge a device.
Yeah, that's a.
And I know that's a tricky question.
That's always a very good question. There's no one answer, and I'm not trying to avoid the answer here. It's a matter of the solution that you have at hand and the user scenario or the requirement that you have. Wireless power charging is not about charging batteries fast enough. It's about charging right enough to be able to have enough power at the moment that you need it. Okay, and I hope that makes sense. But
yes, absolutely.
So effectively, it depends. But I can give you some examples that are probably much more.
Yeah, let's talk about
tangible.
Examples. I think at the end we'll talk about examples.
Yeah.
And what I want to do now is I want to bring on our next speaker. So thank you, Cesar. That was a great introduction to Energous and what you guys are doing. And we'll hear from you at the end when we have some more questions.
Sure. Thank you.
So turning over now to Jen Grenz from Ossia. Jen has been a successful go-to-market strategist in the mobile application and consumer electronics space for almost 2 decades. She started at P&G. She's worked with many companies, and now she's the Chief Revenue Officer at Ossia. So Jen, why don't I turn it over to you, and we look forward to hearing from what you have to say.
Thanks, Tom. Thanks, Cesar. I agree with your comment. I think it's panels like this where we have industry leaders aggregating to help further the entire conversation. It makes us all better. So I am going to share my screen. And as Caesar said, blow it up. All right. I think you can all see this now. So Ossia also focuses on wireless power at a distance. And I think you're going to hear some of the use cases. We have chosen to focus this presentation on applications, go-to-market partnerships that are actively developing product. But we're focused on getting CODA operating at both the 2.4 and 5.8 gigahertz frequencies to send meaningful power at unlimited distance. To couple what Caesar had said previously, it is a very similar like Wi-Fi experience, unlimited distance for Ossia. Meaningful power usually relates to approximately 10 meters. After that, it dissipates pretty negligibly. So just a basic overview on Ossia. We are using principles of retrodirectivity. So the system is built on a physics principle using retrodirectivity, where the receiver actually initiates the conversation, sends a beacon throughout the room, omnidirectional beacon saying, hi, I'm over here. Whatever beacon lands on the transmitter, power is sent back in that exact path, therefore inherently avoiding people. And so I think that's the biggest inherent differentiator that Ossia is bringing to the table. There's a strong IP portfolio, patents globally, and many, many more patents pending. We are working on multiple different chip revisions, chip iterations, I should say, as we move through the frequency spectrums from both 2.4 and 5.8 with different performance specs. We also have achieved some pretty big regulatory milestones, both in the US and globally. We are sending power with unlimited distance globally, including the recent FCC announcement for CODA power, which is really exciting. There's a lot of people currently developing product. Now, I will share the ones that I can that are public in the coming slides. However, obviously, lots of people are developing under stealth mode because they're really excited to bring wireless power to the market. They're really excited about the differentiators that will bring to their product lines. And then we're working on a standard for interoperability between transmitters and receivers. So this is a bit about the CODA technology. Again, we use similar language. CODA feels like Wi-Fi. You would walk into a room and your devices would automatically start charging. We are focused on smaller power devices. So anecdotally, anything, phone or smaller. If we're looking at larger devices, that's not a great fit for the CODA technology. We have spent the last several years working on enterprise scale deployments. So getting the technology ready, not only to license for pilot deployments, but actually roll out at scale. And I think that's been an exciting development over the past 24 months. You'll also see here that there's frequency agnostic. I had mentioned developing on 2.4 and 5.8. We are also exploring higher frequencies and the millimeter bandwidth to deliver even more power with smaller transmitters. So lots more to come on that. As mentioned, I wanted to focus on some of the partnerships that are currently public. You can read about these from our website. We have press releases and blog posts, and then there's lots of media on it, etc. Last year was the year of asset trackers for us as well. We were looking at asset trackers both in manufacturing, but within trailers, within the medical space, within the retail space, pretty much anything that is a high value asset that needs to be tracked for longer than a 5-day period where a battery would typically wear out, and or in an environment where a solar cell is not viable, like an indoor manufacturing or distribution center. This year, we are focusing a lot on IoT. You will see that Ossia had developed a battery-less ESL that we promoted back in 2021 as well, hopefully coming to market with some of our partners here. We've gotten some great traction in Japan, and then working closely with SES to bring different iterations of the ESL to market, both battery and battery-less devices. Moving forward into next year and beyond, I think those deployments will start to scale into enterprise IoT, consumer IoT and mobile devices, and then in automotive. So those are the public people who are actively developing product now. Just to give kind of a pretty graphical example of some of the things we're working on. Back earlier in the year, we had talked about a partnership with a consumer electronics company called Arcos. They are building pet trackers, temperature humidity sensors, the wearable watches, and security cameras. They plan to go to market with those along with a corresponding transmitter at the end of this year, early next year, depending on our parts availabilities. We have partners who are actively building the Coda Forever batteries. So that's a AA battery form factor that is enabled with the Coda technology. So when in proximity of a transmitter, it could be charged forever. It could have unlimited power and not have to be replaced. And then the phone sleeve is also a project that we have a couple different partners working on. That's a retrofitted option as we continue to have discussions with phone manufacturers of full and complete integration. As everybody on this call knows, I'm sure it takes time. The sleeve is a good go-to-market option that gets us there a little bit faster. More in the enterprise space, I think I had already kind of chatted about this, the asset tracker. This is one form factor that was actually built to be on the chassis of trailer tractors that were coming into and out of distribution yards. We deployed this with Walmart and our partners T-Mobile. And then Xirgo technology is recently acquired by Sensata. Gosh, maybe not recently, that was about a year ago. Sensata, who makes this exact tracker. And then here on the right-hand side, you'll see the battery-less ESL. We've done some really neat trials with this where we can show how many times one can update an ESL without draining a battery. So we put out an announcement that we were able to achieve 16,000 updates in 16 days. Obviously, that is far more than any retailer would want to do, but it shows that there will be no battery drain. I mean, it's a proof point to say that you can dramatically influence the point of sale brick and mortar experience by offering a battery-less ESL. These are just kind of pictures of our upcoming transmitters. What you'll see here, both of these, despite the different colored light rings, which just shows the status of charging, this is the newest transmitter coming out from Ossia this year. This is our 5.8 system. It is a 40 by 40 form factor. Soon it will be reduced to 30 by 30 centimeters. This, I think, would be able to sit on a tabletop, on a bookshelf in a corner, and or be plugged into the wall and lay flush against the wall. So it's a good application for home environments. And then just to kind of summarize this, you know, we're feeling very excited about our growing patent portfolio. We're feeling even more excited about the partnerships that have come to us. Everybody on this panel knows the world is ready for wireless power. They are contacting us every day, asking for wireless power to be deployed, asking for those integration partnerships and those licensing opportunities. So where Caesar left off saying, the time is now, we couldn't agree more. The time is absolutely now. We've all worked hard to get where we need to be from a regulatory standpoint, from a technology development standpoint, and I think these products are starting to roll out, which is great for everybody. So that's it from my side. I will stop sharing.
Jen, thank you so much for that presentation. Couple of questions. You talk about, again, I'm going to ask a similar question. You asked one, you mentioned unlimited distance for power. Can you describe what that really means in your case?
Yeah, it's gonna be
pick it out. Pick like ESL or.
Yeah, similar to the explanation that Caesar gave earlier. We are working on radio frequency. So our rollout for unlimited power is going to be the farther away you get from that transmitter, your power is going to get less. We think that there's a meaningful power envelope delivered at 10 meters. If you were to look at an ESL deployment, there would be multiple transmitters installed in a store and infrastructure, much like a Wi-Fi mesh network. One of our transmitters at the 60 by 60 centimeters can power about 2,000 ESLs, and that's within a 3 to 5 meter radius.
Okay, great. That's fantastic. So again, to our WCA faithful, spectrum means everything. And so you're talking about 2.4 gig and 5.8. Those are very familiar frequencies. How do you keep the peace between Wi-Fi, CBRS, and some of the other things that are going on in that space?
Yeah. So again, I think we're seeing the less crowded spectrum being obviously 5.8. And our interference issues are mitigated there, less so than in 2.4. We are trying to deploy some smart channel hopping to make sure that we are not interfering in any environment. And so far that has been successful.
Fantastic. Well, thank you. I'm sure we'll have more questions. People, we keep getting questions from people asking who are your competitors. I think we can talk about that as a group, but several companies on this call today are actually competitors, but they're looking at the market slightly different and taking different approaches to that market. And we should applaud the innovation that each of them have in their given markets and the approach and the way they're tackling the business. This is a real business now. I'm going to keep saying this to people until they believe me. But wireless power is not something in the Jetson age. This is stuff that's being deployed. We're going to move on to our next speaker. And I think I saw a recent press release, and let me introduce him first. Charlie Green, welcome. Charlie is the COO and CTO of Powercast. And thank you for being with us late. Charlie's in Pittsburgh. And so our East Coast contingent is here. Dinesh gets to claim the UK, but he's sitting in Seattle at the moment. So we can't really give him that. But I think, did I just read something, Charlie, that 10 million chips, you just crossed over 10 million chips shipped? Is that
yes.
Did I make that up or is that real? That's a real number.
No, that was announced about 2.5, 3 weeks ago. The last 2 years, we've shipped over 10 million chips.
So if you didn't think that there was a real market out there, Charlie's been in this business about as long as anybody who's been in wireless power, and Powercast has been around for quite some time. And I hate to steal one of his slides, but I always find it amazing in emerging markets that Powercast has been profitable for 10 years. And congratulations on that, right? You're developing new stuff and you still figured out how to make money. So we're always excited to hear that. So let me turn it over to you, Charlie. You can start sharing and we can keep talking.
All right, let me go ahead and. Okay. All right, can you guys see that okay?
Yes, sir.
All right, great. So, thanks for the intro, Tom. I'll give you a little bit more background about myself, and then I'll go into Powercast in a little bit more detail. So I've pretty much been in the RF wireless power space my entire career, dating back over 20 years, the University of Pittsburgh, where I was doing RF chip design on RF to DC converters. Came out, started at Powercast, pretty much been with the company since day one. And I'll roll into the next slide here. We were founded back in 2003, so I've been with the company about 19 years, focusing on RF wireless power. We've had product in the market since 2007. And in terms of our team, we have a great team here in the Pittsburgh area, about 20 engineers, spanning both RF electrical, mechanical, and software. Really a complete team that can bring not only technology to market, but products to market. We have 77 issued patents, early and fundamental IP on being able to do both RF wireless charging and RF harvesting. And I'll talk a little bit about those later, how we kind of differentiate the two. We have a full product development lab here with state-of-the-art equipment, in-house prototyping capability. So it makes it very easy for us to work with our customers, understand their problems, and get them up and running quickly with our products and technology and get those incorporated into their products and get them to market. We have, just like the other panelists here, we have numerous regulatory approvals. We've had Part 18 approval since 2007. We were the first one to get that for wireless power transfer. And likewise with Part 15, we were the first to get that for wireless power transfer back in 2010. And Tom, as you had mentioned, we've been profitable for over 10 years now, really focus on getting product to market, focusing on practical applications for the technology, and really are seeing exponential growth now in terms of revenue and also product shipping into the market. So what are the products that we make and sell? I'll talk a little bit about those here. We're also a fabless semiconductor company. So we have two chips that focus on RF to DC conversion. We have our PCC 110 chip, which is kind of our standard chip, and we have our PCC 114 chip, which was specifically for smart card applications. So it's extremely thin millimeters to get into the ISO form factor. We also have our PCC 2. That is a low voltage boost converter. So I've heard a lot of talk about range and what can you really accomplish and how far can you go. There's a lot of different factors that go into that, particularly what's the gain of your receiving antenna, which I don't think anybody's brought up to this point. Obviously, the bigger you make your receiving area, the more capture area you have, and the more energy you can pull out of the air, convert into DC and power a device. So from a practical standpoint, we've gone from one of our 1 watt transmitters, we've gone about 80 feet, 85 feet from one of those transmitters to power extremely low power sensor type devices doing what are typically battery free applications where we charge up a capacitor when we have enough energy. We activate our PCC 210 boost converter, boost that up to 3.3 volts or 5 volts, whatever the sensor needs. Microprocessor starts up, reads a sensor, throws it over a radio, out goes a BLE packet or some other type of proprietary protocol packet, and that ends up back at a gateway, and then the sensor runs out of energy, and that whole process starts over again. So our application's typically up to about 85 feet away, but we're working on some stuff now to double that, which I think will be out pretty soon here. On the transmitter side, we have been heavily focused in the 900 megahertz band, the 902 to 928 megahertz band, with our PowerSpot and our Powercaster product lines. Those have both Part 15 and Part 18 approval. The PowerSpot transmitter is more targeted towards consumer electronics, where the Powercaster is a little bit more rugged, a little bit larger, and that's targeting more commercial application and industrial applications. Looking at our chips, they're the most efficient RF to DC converter chips on the market today. We're up to 80% efficient in converting the RF that we get from the receiving antenna into usable DC. Those chips are commercially available, have been since about 2010 through our distribution partners. Mouser and DigiKey are more on the development kit side, where Aero Electronics is really where we do our high volume global distribution. In terms of the frequency ranges that we can use, it can be anywhere from 10 megahertz all the way up to 6 gigahertz. The converter chip we have is very broadband in what it can convert into usable energy. We've actually validated in the lab up to 28 gigahertz recently for one of our customers, where that wasn't an expected result, but we've been able to test that and prove that out with our PCC 110 chip. And as Tom had pointed out, we announced just, I think, a little bit over 3 weeks ago that in the last 2 years, we've surpassed 10 million chips of our PCC 110 shipping into the market with numerous customers. And I'd mentioned it earlier, I kind of want to differentiate between RF wireless power or charging and ambient RF harvesting. So our chips are capable of doing both. And that's why you see such a broad frequency range here. We've actually done applications where we use our chip to harvest from NFC readers in smart cards, along with other frequencies as well. So given the broad bandwidth of our chip, we can actually take advantage of multiple bands simultaneously in certain applications to give a summation of power to be able to charge a battery faster or to power up a supercapacitor faster. To talk about some of the products that are in the market. You've probably seen these if you visit us at CES before. Some of the public ones, Sport Core, it's a really neat application. It's a smart cricket ball launched by Kookaburra. Obviously, with something like this, you can't have a USB-C connector on the side of it because it's going to get damaged, and it's also going to throw off the balance of the ball. So good solution for wireless power. We use a transmitter. That's the black and green base that you see there. This transmitter is actually 2.4 gigahertz. It does both power and data over Bluetooth to be able to charge the small battery that's inside the core of the ball. And that core also has a bunch of different sensors in there that can monitor the speed and the spin, acceleration, impact of the ball to allow you to do live analytics during the game, or use it for training purposes to understand how much spin you're getting on the ball, things like that. The second product here is Tag by British Airways. This is an example of RF harvesting. So the Tag has our chip inside, and it actually harvests from RFID infrastructure in airports to activate the Tag, which this is actually a security feature that was requested by the airlines to make sure that the Tag is not hackable. You either need to press the button on the Tag, or you need to be in the presence of RFID to securely wake it up. That way, once the itinerary is set on the screen, it cannot be changed. And that itinerary is sent over from your smartphone. So today you can get your boarding pass on your smartphone, and you can also push over the barcode, itinerary, and airport codes to this Tag, which allows you to bypass the printing kiosks at the airport where you get the traditional paper strip. And it also saves a lot of paper going into the landfill. The third product here is a grip for the Nintendo Joy-Con controllers. So somebody had mentioned earlier about not needing to necessarily charge a battery 100%, and it's a bit of a different thought process. This is a great example where you don't need to 100% recharge the battery. You only need to give back what was used during a gaming session. So you may use 10, 20% of the batteries in the Joy-Cons. You can set the controller down. Our power spot transmitter will connect up with the grip, send energy over to recharge the batteries. We also have 2 undisclosed customers that are over $5 million a year in revenue. And we're working with a lot of other companies. We have 3 Global 100 clients in development right now to kind of back up the 2 that are over 5 million, and then numerous other customers. I always like to say this is a very horizontal technology, a very horizontal, our products can go into many different end applications, from consumer electronics to industrial IoT, medical, automotive, and we typically as a company are working with partners in each one of those verticals because they have intimate knowledge of what's required for those products, and we bring a solution to that to be able to power it or recharge it. So just kind of some closing thoughts here on the market in general. Caesar had given some numbers earlier. It's easily billions of devices that can be affected and be powered or recharged using RF wireless power or RF harvesting. I think for us, what we're seeing is the real differentiator is that freedom of placement. Qi is a solution today, but it's very position dependent. If you move a little bit, the charging people want to get off the charging pad, have the ability to place a device on or a desktop and recharge. And also the messaging is becoming extremely important. And I think companies' mindsets have been changing, that people would be green when it saved them green. Now they're starting to look at how customers are viewing green and their messaging about being green. And a lot of that comes down to battery free, eliminate batteries going into the landfill. And like I had mentioned earlier, we're currently exponential growth in terms of revenue and chips shipping into the market. As we continue through 2022 into 2023, you're going to see a lot more consumer electronics products and even industrial IoT products that are coming into the market. Explosion of new devices. utilizing RF wireless power in the form of not only charging, but also RF harvesting. I think both of those have some very unique capabilities and can really differentiate products. So with that, I'll take any questions.
Charlie, thank you so much. That was really interesting. The same thing. You guys are working in a wide range of potential spectrum, and so two questions there. How do you mitigate interference? Number one, and number two, what does that do to your antenna design if people are rolling out multiple systems, multiple frequency systems?
Yeah, so in terms of how we mitigate interference, we use spread spectrum. So we're trying to smear our spectrum out to allow other devices to talk over top of us. And that works very well. I can give you an example. We have at any given time, probably 8 or 10 of our power spot transmitters and Powercaster transmitters in our conference room for demos. And automation system runs in the same frequency band, 915 megahertz. And we have no problem, even with that number of transmitters, having our light switches, our motion sensors communicate with any of the lighting fixtures because we've deployed that spread spectrum technology. And I think Jen had mentioned doing frequency hopping or jumping around. That's also a way to stay on different channels to allow other devices to communicate. And that's why the FCC requires that under Part 15, either spread spectrum or frequency hopping, because it allows everyone to kind of be a good neighbor to everyone else, and everyone can still continue to either communicate or, in our case, send power. Gotcha. And in terms of your question about the different frequency ranges in the antennas, that comes down to antenna design. So whether we've done applications where we have a coil for 13.56 megahertz, and that same coil is designed to resonate at a higher frequency, such as like 915 megahertz or 2.4 gigahertz. And then our chip can take in both bands simultaneously and convert them into usable DC. So it's more of a antenna and tuning type exercise. The actual chip itself remains the same. Gotcha.
And I'm going to ask another interference question as it came from the audience. As you know, there's a lot of interest recently in LoRaWAN with helium mining and all sorts of other applications that are out there. And so the logical question is, you're sitting at 915 megahertz. Any issues with interfering with LoRaWAN networks?
Again, I don't see an issue with that, given our building automation system uses very similar radios to do the communication from all of the sensor devices, which are battery powered, to all the controllers that are in the light fixtures. And we don't see any interference from our transmitters and in a large number of our transmitters to those types of systems. So as long as you're designing a product with good adjacent channel rejection and things like that you're going to do standard design practices, you should have no issue communicating when one of our transmitters is present in the band.
Thank you. That's a good answer. Question from the audience: what are some of the best use cases for your chips?
Like I said, it's a very horizontal technology. So we're doing a lot in sensor type applications. That's really where we started making our money, was in sensors and being able to power things on rotating machinery where you couldn't run wires, or robotic arms where repeated flex over time would break those wires. And now we're starting to move into more consumer-ish sensor applications, and also pure consumer electronics where we're recharging mobile and computer peripherals. I mean, I think we differentiate a little bit from Energous and Ossia. We're not going after the cell phone. We don't see that as a good potential market. We're more focused on the things that go around the laptop, the things that go around the cell phone, because you're starting to see an explosion of those low power Bluetooth devices that are interacting with the phone and the laptop. Those are great candidates in the consumer electronics world for recharging via RF.
Perfect. And one last question, and then we'll move on to our next speaker. This is an interesting one, and I don't know how much data you have, but what kind of failure rate are you looking at with wireless power for products? The change, how's it compared to traditional products and wireless power products?
Well, I guess in terms of manufacturing, I can talk about like our yields in terms of manufacturing, because we haven't seen any product failure in the field. But in terms of yields coming out of our factories, we're at like 99.97%. So doing a lot of work on making sure that we're designing products that are robust and are repeatable. Because obviously, if we're tuning something for a particular frequency band, it has to have a stable input impedance. If that varies over product to product, then you have issues tuning. So we've been very stable in terms of our yields on manufacturing and not had really field failures. I think probably the biggest problem we might experience with something like that would be if the product's not properly designed and that there's the capability to have an ESD event on the input of one of our chips. That would probably be where you'd probably see the most failure potential. But most of the time with RF, you can have the antenna inside of the enclosure, so it's protected from those types of events.
Well, thank you, Charlie. That was very informative. If you could stop sharing your screen, we'll have, I'm sure, more questions once the rest of the panelists get their opportunity to talk, and we'll be back to you then. Well, everybody, welcome again. And our next speaker is focused on a different type of wireless power, wireless magnetic resonance for power. And that's Jeff Yen, the founder and CEO of ETI. Jeff is a trained physicist and an entrepreneur and is delivering products in this market today. And I think he's going to talk about one of the applications in that area. So Jeff, over to you.
Great. Well, thanks everyone. So let me share my screen really quick and then let's start this. Great. Well, thank you everyone. So I think, so if you guys are interested in our previous WCA talk on wireless power, we actually do cover sort of a range of a different application and the technique through frequency range. So I think one of the things that I guess ETI is different is about the frequency that we're choosing. But I will not go into detail until later. So, well, thanks for the intro, Tom. So I think as you hear from the previous speakers, I think wireless power industry is in a very exciting stage where it starts enabling many possibilities. So as many of you already know, the earliest work that wireless power transfer has contributed back to Nikola Tesla in the early 1900s. So where the idea of electrification was just at its infancy and the wireless energy delivery was way ahead of his time. But today, the wireless power transfer is gaining more and more traction and more popularity because the increasing demand of the devices that needs the power and the flexibility around our lives. So my name is Jeff Yen, the co-founder and CEO. So today, I'm going to focus just on how wireless power transfer revolutionized the lighting industry. So I'm just talking about almost exclusively in the lighting application. So I guess I will start with the why. So why do people need light? So it can be breaking down into two categories. So utility and aesthetic. For utility, it's based on the needs of illumination to perform tests that otherwise couldn't be done, like miners working underground in the mines, or just for you and me to be able to see when the sun is down. So on the other hand of the part is the aesthetic. So it can be for the mood changing or for emotional pleasing, like a Christmas tree that light out in your front yard or in your living room. So, or finally, there are lights can serve both as a utility function and as well as aesthetically pleasing. So what functionality do light fixture need to achieve utility and or aesthetic? So there's mainly three functions. So one is the luminosity, which serves its primary function. And there's an interactivity with people, which is actually be able to control and how to interact with the light. And then finally, it's a flexibility to be able to rearrange or reposition. So for the past 100 years of electrification, the technology advancement of luminosity has changed dramatically from incandescent bulb to the high efficient LEDs, as well as the interactivity of the lighting with people. So from the mechanical pole chain socket from each bulb and to controlling the light using the smart devices. So the only functionality that hasn't really changed is actually the flexibility. So the question is why? Why is that? Why is the flexibility of the light hasn't changed for the past 100 years? So because of the wiring. So because the way people provide power to lighting fixture is the same. In fact, we call that fixture because it is fixed. So there isn't much of a technology advancement around flexibility because they are always tethered by the wire. So when a house is built or an office building is constructed, the design and where to put lights needs to be predetermined and very difficult to change once it is in place. So granted, not all the lights need flexibility. However, there's a significant diminishing value of lighting when it is not flexible. So where do we need light be flexible? So I'm here to just provide a few environments and example that can benefit from the flexibility. So I was starting with the smallest space, like a closet. So a closet space is usually the darkest place in the corner of a room, and hard to choose. It's hard to choose a cloth when the only light is on the ceiling, where it got blocked by multiple shelves and other clothes. So it would be nice to have a lighting element that can be positioned and illuminate properly to showcase the color of the clothes that you want to wear today, and bright enough to search for the matching shoes that you're gonna wear. So it will be a good zones to have a more flexible lighting. So another example in a larger area is a drop ceiling environment, which is in the commercial buildings. So since the commercial real estate usually need more frequent changing of lighting, change of a design layout of the space, depends on the seasons, depends on locations, and the type of a business. The lighting element of this type of a ceiling changes more frequent than the others. So having a flexible lighting system that can be changed or designed quickly and easily is valuable to avoid high cost of electrician work or time delay. So it's a place that is hard to access electricity, and once the system, so it's a very hard, it's a higher cost and then longer time delay. So for this type of application, it is important to have a more flexible of a lighting element. So the largest area that I'm showing here is outdoor landscape. Outdoor landscape is actually quite an interesting market by itself. So I think the problem is it's very hard to access the electricity in the outdoor. So usually you spend a lot of money to waterproof, to lay down all the wiring, and then you actually place the light in the location you want. And it takes and then that's it. You can't really move them around, or you cannot change the landscape look afterward. So all these examples I was given, there are a few common themes actually. So one is that there are sizable space, and there are multiple lighting elements need to be simultaneously getting power or getting lit out, which with a significant power. So with this requirement, which is coming to our technology, so ETI's loop technology. So I would like to introduce this technology that we are striving for maximizing user flexibility by creating the wire-free power zones. So I will start going to more on the technical part, starting here. So the concept, I will start with the concept. The concept is quite simple and straightforward. So you have an area or a zone that you want to have a wireless power. Then you set out a geometric parameters using our loop. Then anything that are inside the loop can get power by having our receiver. So this is where we're different than the other speakers that speaking today. they are using a higher frequency, which generally the transmitter and receiver size will be smaller. We are using something called magnetic resonance and at a low frequency. So we're at a 6.78 megahertz ISM band. So in that frequency, which is about 40 meters size, since we are in the 40 meter span, that means that anything that within the 40 meter size to us is a near field, not a far field. So we are not doing the radiation type of a wireless charging. We are doing near field type of wireless charging. So, or powering for that matter. So in this picture, so usually there are two questions that people ask. One is, is it safe? And then the second is, how much power can you deliver? So I will address that two questions in sequence. So the picture I was showing here are 12 feet by 12 feet size of an ETI loop. And you can see there are 3 lights that is holding by 3 of us. So each of this is receiving about 5 watts of power. And this system that you are seeing can sustain up to 300 watts. So that means we can actually put out to be 60 of this 5 watt lights, or we can put out 300 of a 1 watt device that all within the zones of this loop. And this loop size can be as small as 1 foot by 1 foot, like 30 centimeter by 30 centimeter, all the way expanded to the largest we built so far is 20 feet by 20 feet, which is a bit larger than this picture. So the idea is that we create this magnetic resonance energy space around this volume. And so we are not in particular doing the wireless charging or power. We are merely providing the energy source for people to tap into. So it's very much like the wall socket that in your house, you don't really actually use the power if you don't plug something in. So we actually create this energy field that if no one is actually needing that, it will just maintain a minimum power to have this energy. But as you bring more and more devices into this zone, then the system will notify and they will increase the power level to deliver to this energy. And I think so one critical thing is always safety, because I think safety is actually, fundamentally for everybody is talking about here as well. We are using basically 6.78 megahertz, which is a very low frequency. And also we are doing that purely in the magnetic field. In fact, our magnetic field strength is actually lower than the Earth magnetic field. So it is an extremely low field strength that people will immerse in. But yet we are able to provide power from 5 watts to 20 watts level and a multiple of them simultaneously. So I think one thing to say is that we are not in the radiation field. So we actually have the physical dimension of the loop has to be encompass the zones that we want to power. And then once you are inside the zone, the field strength that human actually immerse is almost negligible. And obviously we clear through the FCC for human body absorption and also the part 18 for our ISM band as well. So that being said, I want to show just an example of the flexibility of a ceiling application in this video.
Hi, I'm Connor with ETI, and this is our ceiling light demo.
So this is a stem loop you saw earlier.
Receivers. It is wirelessly powered by a loop in the ceiling. They're just attached to the ceiling with a magnet, so they can move around anywhere you like and always be powered. We can power any type of light, like powerful accent light, or pendant light that might sit over a table. We can wirelessly control each of these lights with a switch. They can turn on and off in different groupings. That's our demo. Thank you.
So this is a sort of a preliminary demo to show about, back to my point about flexibility. I think the flexibility is something that is lacking in the lighting industry that we are actually enabling. But lighting obviously just one of the many applications that we are able to accomplish. But so for that being said, hold on, let me change to the next slide. I guess. So I will conclude this is that, since I only talk about lighting application, but this is our technology is an enablement. So it's enable something that can be new, can be either wire-free and battery-free, or something is wireless charge, or like lighting is pure wireless power. So we are always welcome the inventor and the innovator to collaborate and join our journey. So we have already had a certified licensed product to the market last year. And we are actually having this evaluation kit that we are working with other potential partners. So my name is again, Jeff Yen, and thank you for your time.
Jeff, thank you very much. It was really interesting to take an approach of just looking at a specific use case and looking at lighting and how it can benefit from wireless power. Can you talk about other areas? I mean, so you mentioned the loop can be 1 foot by 1 foot or 12 foot by 12 foot or literally any size. How do you scale the power? So if somebody has a room and they have 100 lights or 200 lights and they want to do a floor of a building, how does that work? How does that scale?
Yeah, so I think I will address this a little bit differently. So think about your traditional wall right now with a socket. So that usually can sustain 1 kilowatts of power when you plug in. If you actually draw more power, there will be usually a safety circuit breaker that will trip and then shut down. So our transmitting system is very similar for that matter. We actually have a system right now. Right now we have a 20 watts up to 20 watt system that is up to in the market. We are developing a 100 watt system for this year. Our power level actually can be modularized by cascading multiple our amplifier together in the chain of a loop. So if you want a kilowatt, if you have a 10 of this chain together, then it can actually sustain up to a kilowatt. So, but in terms of this, the wall analogy, if your application that require more power than what we can supply, there will be a safety shutdown. But since it's a modular, so it's always depending on the application basis at this moment. So, so the receiver end is also another story because we inherently designed the system to be a compass one-to-many. So we can power, like 10 device or 100 device or 1,000 devices for that matter. So it depends on what is our maximum addressable power for our transmitting system can sustain.
Well, thanks, Jeff. We have another question, and specifically for you. And they mentioned that resonance can safely deliver much higher power loads, tens and hundreds of watts than other technologies. What range between transmitters and receivers do you think are most practical for applications?
To answer that question, I think this is also back to the RF base of the wireless power. I want to mention the technology was invented and designed for solving specific problems. So there's no one solution for wireless power charging can do everything. So usually you select the direction that you are going and you do R&D to that area. And the safety, always the top priority for every application people look into. So for the magnetic resonance, I think the resonant technology is, well, first of all, this is why I said about Nikola Tesla, because he was the first person doing the electric resonance wireless power. But at his time, it's just too early. But for magnetic resonance, right now, there are electric vehicle charging, which is high power. I will say anything that going to 10 watts or 100 watt level. Well, by the way, Dinesh will be able to address this much better, I would say. But yeah, so I think though, as the power level of an application gets higher and higher, then the technology will shift into a magnetic based system. So if you think about the harvesting all the way to milliwatt to probably a watt level, you could have a RF base of system ranging from the 915 megahertz all the way to 28, 58 gigahertz. But as you go into the higher power region, since a human absorbing the microwave, so the magnetic base become more preferable because it's a lower frequency. Human doesn't interact with the magnetic field as much. So you will see, cell phone or laptop charging or some other type of a higher power devices will leaning toward the magnet or magnetic induction or resonance. So that's probably the breaking point, I would say.
Thank you, Jeff. We have another question from the audience. Really interesting. What other areas besides lighting might be used for this technology?
I think, well, I think the IoT is interesting. Well, I will say this way. So our technology was designed to be a very wide range area to encompass, hundreds to thousands of devices at once. I think the other area I would say is probably actuating, like actuator. If you have something that is motorized that need to move, it is very difficult. You can use harvesting or charging the battery, but our system potentially are able to directly given enough power that you can freely move the actuator in the space, whether it's an industrial application or a commercial application or residential application. I think one of our focus right now is the loop technology, because this is actually a brand new technology to the market that we actually spend. So our company has been around for 5 years to 6 years at this point. So we accumulate our own patent portfolio to do the space that we are doing. But really the core thing is that the loop technology to be scalable, to be install base, to be implemented to the chair or to a table, to the wall. That is actually where we are today. So I do envision in the future, people will tell us what other product they want that is, that we haven't thought about.
That's great. Jeff, there's one other question and then we'll go on to our next speaker. Question comes from the audience. In the 12 by 12 loop will still radiate some power at 8 megahertz. What is the maximum near field power you can extract while not violating FCC requirements?
So we actually need to start. Well, this is a little bit technical. So the FCC does require there's a certain level of a radiation field pattern at 300 meters away, but usually you do that in a chamber, which is either 5 meter or 10 meter, then you extrapolate that. Our system was designed, since we are using the loop, and then this is a very much of a Faraday's law, right-hand rule of physics 101. But really, if you think about it, we are actually creating a magnetic dipole moment in the loop. So when you go far away to look at our system, it is actually like a single point, which doesn't radiate because that's the whole thing is confined. Our technology core is probably what people will call antenna design. So it is the loop itself. It is called people do call it as a loop antenna. However, since we are making a very inefficient radiator, so instead of a radiant at a high frequency and a very high gain, we are actually minus 60 dB gain. So we actually don't radiate at all. Everything is very inclusive in the zone. So if people stand far away from the loop, they can see a very quickly diminishing of the power that they can receive. So almost immediately you don't get power.
That's great. Well, thank you, Jeff. I'm sure we'll have more questions when we get to the end of the session, but let me turn it over now to make sense of the wireless power industry in general. We have Dinesh Kathani. Dinesh is a founder and chief analyst at Wireless and Wireless Power, and we're happy to have him here today to talk about this. All of us who are in the wireless power space know of Dinesh pretty well, and so we're happy to have you share his thoughts and research on the wireless power space. So Dinesh, over to you.
Sure, very much. Thank you. But again, I would say good morning, good afternoon, and good evening, understanding this is a global event. Before I start, Tom, can you confirm, can you hear me and can you see my presentation?
Yes, perfectly. Thank you.
Perfect. Yes, today I'll be talking more about wireless power and in a very brief sense, see how the energy harvesting technology is being embedding or complementing or to some extent competing with the wireless power as well. So again, very, very brief structure on that. But before that, just very, very quickly, like I said, I'll have a couple of slides on my company as well. Obviously, there's a few slides on how the wireless power technology landscape has been evolving. I must admit here that, normally I'm working on wireless power for what, nearly 6 years now. 6 years now, and I normally update the presentations or the market structure once in a year. But I would be honest, like since the last 1.5 year, I'm seeing so much of activity happening in the market that even an update of 3-4 months back of what I heard, what I'm delaying to my customers, is looking very redundant. So that fast is how the market is evolving. So I'll touch base on that as well. There's a couple of slides on how the technology adoption is going across applications, and 1 or 2 slides on the size of the market or the size of the market opportunity for us. Just before that, basically it's about me. I'm in my company. It's called Wired and Wireless Technology. It's a strategic analyst firm and a consulting firm where the focus is to deliver data, insights, research, and also help companies to build strategies. Company founded by our believers, our clients. And again, it's the focus, like example for myself being a subject matter expert, is to operate like a trusted advisor or like a strategic business partner to my clients or the industry. The research is conducted across the entire supply chain, be it component manufacturers, wireless power technology companies, semiconductor companies, component manufacturers across all the structure as well. And the vision is to continue to be the most trustworthy and sought after analyst firm in the areas that we excel into it. And this slide basically talks about how adoption is evolving across applications. And as the adoption evolves across application, you can see here there are more than 30 applications which are covered. And that becomes the scope of our research as well. I cover applications which sees a lot of attraction in the market. So these are the 30 ones which are covered, from automotive segment to mobile to computing applications, home appliances, variables, IoT, robotics, all the applications covered. So my research covers a lot of good data insights on these applications with regards to the wireless power industry. Now let's go back. Let's go to the wireless power technology landscape, how the market is evolving, how the technology is evolving. So now some of you would have seen my presentation last year when I was presenting at Wireless Communication Alliance, would find some slides familiar, but again, there is a lot of update that has happened in the last 1 or 2 years, which would be worth looking into it. So like I said, the wireless power market is evolving at a very faster pace now. And not only that, there's not many new solutions coming in the market. And each of the solutions, and many of the solutions are catering to the wide range of applications, considering what the various use cases are. To start with, on a segmentation basis, on the frequency, we have low frequency solutions called a magnetic induction technology. Magnetic induction type of technology is a tightly coupled technology. We are familiar with this. It works on a frequency band of 100 to 200 kilohertz, even 350 kilohertz solutions also available in the market here. We have a very popular wireless power consortium, the industry body who looks after the standards of this particular technology. The standard is basically called the Chi or the key standard. Saying so, there are not many proprietary solutions available also in the market which covers this technology. Power classes, again, from a very low power to very high power classes what been adopted by the low frequency solutions here. Similarly, within the low frequency, we have magnetic resonance type of technology. Relatively is a loosely coupled technology working with a different frequency band of around 79 to 80 kilohertz frequency levels. This type of technology is basically used for electric vehicles currently, but many other applications are adopting that as well. And we have SAE, Society for Automotive Engineers, ISO contract and all, which are also working using this technology as well. So we have, and from a power perspective, we have very high to ultra high level of power levels which are being used wirelessly. And now coming to the high frequency type of technology, we have magnetic resonance, which comes also in the high frequency segment. Again, it's a loosely coupled technology. The frequency band is around 6.78, not around, I would say 6.78 megahertz. We have Airflow Alliance, the industry body who takes care of the standards and specifications for this type of technologies. Saying so, the technology is called, the standard is called the Airflow Alliance Resonance. Saying so, there are also proprietary solutions, not many other players in the market who are using proprietary solutions using this technology as well. Again, the power classes from an application perspective is a low power to a high power applications using high frequency magnetic resonance. Within the resonance, we also have NFC based charging, wireless charging, which is called NFC charging. Again, it's a loosely coupled technology. It uses 13.56 megahertz NFC Forum doing an excellent job publishing a standard on this. It's called the NFC charging standard. It's a very focused application, a focused technology currently in its current state. The power levels are very low to a low. It's around, I will come to the power levels in a minute again, more specifically there. And then we have ultra high frequency solutions. Most of the companies on this panel are working on that segment of the market, the high frequency. It's also called the distance charging technology. If I may say distance wireless charging technology, it's how I segment that market as well. And when we look into that, we have RF-based solutions in that segment. We have ultrasound-based solutions. We have infrared solutions. We also have some 5G applications, 5G networking being used just at the initial stages at the moment, looking into that technology. I classify that as an uncoupled technology because of the distance that it covers. Is from a I would say from a near field to a very far field. We saw, I'll not go more details about the frequency bands because Energous, Ossia, Powercast have all talked about what different frequencies they have been using. So we have wide range of solutions here as well. From a standard perspective, there's only Airflow Alliance who has a standard available that also for the from the RF perspective, but like we can see here, many of the, except I would say Energous, we have other companies promoting their own proprietary solutions here as well. From a power class perspective, we have a very low to a low and a very low power applications which are looking into that. So this is basically a summary of how the current market segmentations are, how the technology has been segmented from a frequency, like I said, from a very low to a very high applications. Coupling standard is a very tightly coupled to a loosely coupled to uncoupled solutions available in the market. From an ownership front, we have industry standard products there, as well as many proprietary solutions which are gaining a lot of traction and adoption in the market as well. And wireless power is getting to across power bands from a very low, which is like a less than 1 watt to even 20 or even 200 kilowatts. Ultra high power solutions have been looked at, especially example like electric trucks and all those things looking into these applications. So this is how the technology is evolving. I would like to summarize here what has happened in the last couple of years' time. Like I said, the adoption has grown beyond toothbrushes and electric smartphones. As example, if you see here, the column it says number 1, which is emerging applications. So you see within each of these frequencies or each of these technology spectrums, there are so many different applications being looked at. So there are companies who are using, low frequency solutions from smart watches, smart phones, electric toothbrushes, AGVs, AMRs to public spaces. More relevant for this audience could be the ultra high frequency, where we can see infrastructure charging from a public spaces perspective. We have IoT sensors, we have wearables, hearing aids, smart home devices, we have medical devices, and in multi-mode solutions looked at. So if you can see, the market has evolved into so many applications. That's why we cover also so many applications as well. Because they are different applications, they have different power levels. So if you also see, the market is nicely getting segmented from a power class perspective, even though I believe that there should be interoperability across power levels. So it should be irrespective of what power levels your particular application requires, you should have a very standardized transmitter, if I may say, which can adopt different technologies or different power levels. But again, like we all know, this wireless power is still at the very nascent stage. I'm sure as the technology evolves, as the market evolves, there'll be a lot of interoperability across technologies and across power levels as well. We also saw in 2019, we have NFC charging, which came into the market, which was launched there. That was in 2019. In 2019, we also saw WPC launch their key standard, which is the high power wireless power solutions there, specifically catering to the kitchen, small kitchen appliances market as well. So that's how the market evolved in 19. In 2020, again, we saw what we looked into is that Apple launched their own proprietary wireless power solutions, which is called a MagSafe, which is basically for currently being used in their mobile phone expert as well. So again, a lot of activity in 2020 as well. MagSafe was one which is compatible with the Qi standard, but also going beyond that into their own proprietary solution as well. So that's 2020. 2021, again, this could be quite interesting as well. A distance wireless charging market got more and more traction in the market. We saw many new products, many innovations, a lot of advancements from the existing companies, players. We also saw quite few new players entering this market as well. Again, there is a lot of activity, there is a lot of scope in the market, so we can still see continuation of new players entering this market segment as well. But at the same time, we also saw, energy harvesting being there for a long time. We heard Powercast saying that they've been doing this work for more than 10 years now. But now this energy harvesting also becoming, I would say, into the limelight, and it's getting more and more popular. A very small example I would give is Samsung, had launched their Eco Remote, which is basically using energy harvesting there. And there are a few other applications which I cannot mention in this current forum, is that, which are also using energy harvesting. So the question really lies is to know where is energy harvesting, how it's placed within the wider wireless power technology landscape. I would say, again, it all depends upon how it is, whether it's complementing or is complementing, we can leave that out to the application providers in that market as well. But just one more slide before I go into more details, is what we expect in the next 2 or 3 years time. What I'm saying is, I think I will still expect, while we have already seen advancement in the current technologies, my research says that there'll be still new technologies coming in the market, which has wireless power. So this is not the only thing that we'll see for the next 1 or 2 years. I will not be surprised if there are 3 or 4 more columns or 1 or 2 more columns added up on this slide, which talks about the new evolving or emerging wireless power technologies. Just wait for, I would say, a couple of quarters, if not 1 year, and we'll see some more activity happening in the market. It's very interesting time, exciting time. So just be on your, I would say, wear seatbelts and be active there. And also what I'm also seeing, very interesting topic, and I'm glad I'm seeing that as well. I'm seeing introduction of hybrid solutions coming to the market, multi-frequency solutions which are using either a magnetic induction type of solutions or a magnetic resistance type of solutions. Again, it's for one applications, but based on where the application being used, how it is being used, the frequency band changes, and there is a good interoperability or this good seamless power which is being going around irrespective of the frequency level as well. Again, that is a very nascent stage, but I guess that is very, very important that we look into hybrid solutions where these are the applications. If I'm in the office, this is what I'll be using. If I'm outside the home or office, this is what I can be using. And I'm starting seeing that. So we'll see more of that in the next 2 or 3 years time as we move on. So that's basically on how the technology is evolving. This is very, very basics. If you all want more details, surely get in touch with me. And let's go a little bit more on energy harvesting. Well, just a couple of slides here, again, with due respect to all the companies on this panel and also some of them attending this webinar as well. What I would like to say is that while wireless power adoption increases beyond smartphone to wider power profile applications, like, from a small battery powered devices to electric vehicles or electric trucks and all, energy harvesting is set to complement the wireless power in the current state. In fact, by focusing on some subsegments of these markets where wireless power is just being targeted at, or by having different offerings. And that is, I'm seeing that more relevant, and I'm sure most of them agree here, is that it's happening within the long distance charging segment as well, or long distance charging, RF, infrared, or if you look into all those other segments as well, is we look into it and how energy harvesting can play a role there, complementing or competing role there. And when you look into that, I would say that if it's this segment of the market, which is where wireless power and energy harvesting can work either together, compete with each other, or complement each other. I think Charles made a very good example of how their technology can be used when you're looking into wireless power type of solutions, or you're looking into energy harvesting as well. From what I'm gathering while speaking to many companies who are working on either or both of these solutions, whether it's wireless power, energy harvesting, is that both are good, both have both have a very differentiated place in the market as well. It all again depends upon the use cases. I would say not only depends upon the application, but also depends on the use case of that application, whether you want only power levels, or you want data and power, or you want more reliability, or whether you want continuous power. That's where, example, if there's a battery powered devices, if you want continuous power, I guess, again, at different power levels, then maybe wireless power is a good option. Or if you want, power continuously, but along with the data, or you want to communicate with that application, yes, again, wireless power becomes good. But when you're only looking into a very milliwatt type of application, just trickle charging once in a while and all, maybe then that's where energy harvesting can come into picture as well. Again, I don't want to go more detail into it. It could be a very wider topic to talk about. But again, if you look into that, this is where energy harvesting and wireless power can complement or compete each other, mostly in this segment of the market or these type of technologies in that segment as well. So that's more on energy harvesting there. Just in the next couple of years' time, again, there's so much on this slide, but just to very briefly set you in what we are expecting in the next couple of years' time, applications such as home appliances, computing, automotive, industrial and medical sectors, application in these markets expect to see more and more traction in the next 1 or 2 years' time. So in appliances, it will be toothbrushes, power tools or kitchen cordless kitchen appliances. Mobile ecosystem is already flooded with wireless power solutions there. Automotive segment is there, like I said. So there's a lot wider range of applications happening, adoption happening in the next couple of years' time. I would say from a distance wireless charging segment, which is again, most of the audiences are here at the moment and the panelists here, the applications which are highlighted in the green here, again, I'm not reading out all the names here, but if you see the industry sectors, many of them cater to these segments, whether it's home appliances, infrastructure market, mobile, retail, variables, industrial applications. So if you see the long distance or a distance charging, wireless charging technology, the scope is big. Like I think we already know that market is too big enough. And here I just want to quickly highlight one question which came up, is saying, what is the competition here? I would say the competition is good, which is great. I can see a lot of competition across players and across applications, but I'm also seeing at the same time, I'm seeing healthy competition, which means saying that market is good and there's so big a market for everybody to have a good share of the market as well. It all depends upon how you match the right technology for the right application and the use cases. It what will be considered as a more key question than what is the competition about. And again, I just want to add up here on, while I highlighted the distance wireless charging technology key applications, I have highlighted also the energy harvesting areas where there's a complementary or a competing type of solutions coming here into picture. So if you see there, energy harvesting can not only play a role, electric shelf labels or IoT sensors can be either using wireless power, or they can using energy harvesting, or you can using both of them, depending on all of them. My research says that there are billions of IoT sensors which will require power. They could be wireless power, or it could be say energy harvesting type of technology, but it all depends upon which of them require data, which of them require communication, which of them require continuous power. So that will set across how the market is evolving. There are a lot of other consumer electronic devices which can possibly be charged with energy harvesting, or that's how the route they are taking, which long distance charging may not be having the focus at the moment on. IoT sensors here, stylus pens is also looking into energy harvesting, just not wireless power as well. So these are some of the applications which are highlighted, which are going along with the wireless power charging applications. Now, just one slide about sizing of the market. That's what my key role is about. What is the size of the market? Very, very briefly, I just want to set some few bullet points without revealing a lot of information. Otherwise, I will not be making some money here. Okay, so from the sizing perspective, the total wireless power receiver and transmitter market is expected to grow from 650 million units in 2021 to around 2.4 billion units by 2025. This shows how big the market is. It will be 4 times the market in the next 2 or 3 years' time. That's how the market evolved. Again, these are only 30 applications which are covering. There are many more. In fact, some of them even Charles expanded, which are not even into my scope area as well. And if you look in the total size of the market, there'll be 7 billion units of wireless power receivers and or transmitters that will be shipped in the next 5 years' time. 7 billion units. So we cannot say the market is not small, market is not big enough. We cannot say the wireless power is still not evolved. It has still not arrived. It is already, we will expect around 7 billion devices to be there. And very, very small 1 or 2 points on long distance wireless charging. The market is expected to reach from a less than 1 or 2% share now to double-digit percentage shares. I cannot give the exact number here, but it will have double-digit share of the total wireless power market by 2026. And I'm excluding mobile phones from that as well, which means shows that how big that market opportunity is there. And again, from a wireless distance wireless charging perspective, we have retail and industrial sectors, which are expected to be the biggest segments in the next 5 years. But from the energy harvesting, I would also not only add retail and industrial sector, but I'll also add other consumer electronics or other consumer small devices, accessories or peripheral devices, which also be the target segment for energy harvesting here. So that's very basically talks to you about the technology landscape. It also talks to you about, where we are at the moment and how the market will be in the next 3 or 4 years time. So that's a quick overview, and I'm happy for a few questions if we have time.
Hey, Dinesh, thank you so much for that. If you could stop sharing for me, that'd be great. First question, we talked about, you mentioned the cheese segment of the market, which is the basically one-to-one phone to charger, very location sensitive charging system that's been prevalent for phones. People have seen that migrate now into cars, where cars are now providing charging capabilities. And now Apple has MagSafe. What is that doing to the Qi space? Because there's lots of talk about the amount of power, how much is available, what happens next, and it seems like Apple just put a stop on what's going on in the automotive space. So curious for your perspective.
Again, I would require a lot of time to answer that question, but very briefly, I would say that yes, this shows the pace at which wireless power technology has been evolving. The market is evolving. This shows the pace at which the consumers' expectations from the market. You raised a point about MagSafe. Again, let me specifically say that I would say that's good and bad for the market from how I'm reading it at the moment. So when I say what I say is about good is because, again, like we all know, Apple is looking after better consumer experience. As simple as that. Their focus is very, very clear. We want better consumer experience. And with due respect to the work that is being done with Qi or WPC and all, that is an excellent solution and all. But I guess there are a few constraints. I think we require more spatial freedom. We require more alignment. And plus we also require more high power as well at the same time as well. And looking into the current applications, use cases as well, maybe that's a good solution at the moment. Some say that this could be a step in the wrong direction. Example, MagSafe, or one step back rather than one step forward. But yes, I think if I'm thinking a little bit broadly, I would say this is more like a better user experience. I'm sure consumers are more sure that their phone is being charged as compared to the non-MagSafe environment there. But from the bad perspective, I would say this not. I would say that because the market is already getting cluttered from solutions perspective. So if you see a mobile phone, I can either charge my phone with a 5 watts PPP solutions. I can charge my phone with a 15 watts EPP solutions. There is there's Apple fast charge. There is Samsung fast charge. Each of the Chinese OEMs are using their own different fast charging solutions. Then we have Apple with their MagSafe solutions. So we are into the year 2 and 3. Instead of having interoperability across technologies, we are seeing 6 different standards or 6 different type of solutions. So if I'm an infrastructure company, if I'm a restaurant manufacturer, I'm a restaurant owner, I do not know which transmitter I should put in, whether that should be a 15 watt charger or whether it should be Samsung fast charge or it should be a MagSafe compatible and all. So that has really given slight, it has disturbed the market, like your question was on those applications. So I guess it's time for us to think about what we are doing for the audience rather than only doing it for our own business as well.
Well, thanks for that answer. And I want to thank all of our speakers today, Caesar, Jen, Charlie, Jeff, and Dinesh, for this enlightening panel on wireless power. I'm going to turn it over to some questions now. And this will be for the group. And Dinesh, first, I'm going to ask you if you have any questions for our panelists. 1 or 2 questions you might be able to ask.
Again, I think I asked a question which I think most of the panelists will be facing now. Again, we have so many OEMs example working on, they want wireless power. And again, they know who are the companies who are providing wireless power. So what are the biggest challenge that they face? Because each of the technologies are good in their own sense. But at the same time, because again, the reason I'm asking this question is because I see a lot of lack of awareness about wireless power. There's still so many. In the last 1 month, I met around 50 companies. Most of the companies still do not know about wireless power, or they are not aware about the benefits of wireless power. So how these companies cope up answering those companies as to how their how good is their technology, how good are they better versus the others, but more important, the role wireless power can play in their offering. As simple as that.
Does anyone want to jump in there? So how do we get the industry more engaged with us as providers of wireless power solutions? Caesar, you were about to say something.
Yes, I think all of us are really here working on brand new technologies and technologies that are emerging technologies that have not really opened up a market. So part of the issues and the challenge that we have is educating companies. So when you go to a company and you talk about wireless power, they will get different idea of what that is. I mean, some think it's G, some think it's RF, some think it's something else. So that's one challenge. So educating people out there, potential customers. Also, when we go there, we have to do a good job and deliver. And if we don't deliver, we really stink up the market, and we shouldn't be doing that. So what we should do is, in our particular case, we want to focus, right? And I think if you can focus in certain areas where we can go and make some inroads, and most important, like we do at Energous, show that we're not just a semiconductor company, but we're also a systems company that can implement vertical solutions, where we go to a customer and say, here's a vertical solution. It doesn't have wires, it doesn't have cables, but this is how it works, and this is why it works, and this is how you're going to go build it. And I think there's going to be plenty of work to do that, because as Dinesh was mentioning, I mean, there are billions or trillions of devices out there, and the market is huge. So I would say educating and then focusing in certain markets that should take off first. That would be my answer.
Thanks, Caesar. Jen?
Yeah, I would agree with that. I would also just say, Dinesh, I think it's products in market, right? That's what we're all working towards. And as soon as people see products in market, see it working, that's going to be the education. That's going to be the point where companies are like, okay, this is real, this is here. We're ready to commercialize, we're ready to productize.
Jen, a question back to you from the audience. So you mentioned during your presentation lots of Coda products. Are those going to be Ossia branded, or are they going to be OEM'd? I mean, how does that work?
Yeah, great question. All OEM'd. Ossia is a licensing company. There will be some name attribution for Coda, usually more like a Coda inside type attribution. But these are transmitters and receivers that will be branded by the companies that are putting them out into market.
Perfect. Charlie, did you want to add to the general question of how do we help solidify with customers and make customers more aware that wireless power is here?
Yeah, I think Jen and Caesar touched on it. It's about education. We've been doing that for numerous years now, educating people about what can and can't be done with the technology. I think a lot of it is setting expectations correctly too with the customers about what is practical and what is not practical. Because if we say things that are pie in the sky, it tarnishes the reputation of the industry.
No, that's a good point, because I think in many cases when you are invited into a customer environment, someone may have been there before you and done a very poor job talking about the industry, or delivering on a proof of concept, or understanding the requirements. And so your job, and this is wireless power, but in any emerging market, this is the case, that your credibility is based upon the last guy who talked to the customer about the type of technology you're presenting. So credibility is crucial. So I would agree with that. Jeff, what are your thoughts here?
So my thought is we should have a more WCA event that focused on the wireless power. So this is.
Hey, I was going to say that. That was going to be my closing line.
So, well, but that being said, I do agree with Caesar and Jen, and then because I think one thing is it's a different to talk about a vision than when you engage with the customer to talk about deliverable, because there's always expectation of timing, and I think in the RF wireless power space actually has been working very hard for the past at least 10 years to go through the regulatory compliance, because I think that is extremely difficult process to go through. So I think at this point, with the RF technology being recognized by FCC and then recognized by the safety regulatory body, I think I do agree it's going to explode. I mean, this whole IoT space incorporating into the RF, IoT system is going to be a very, very fast growing market. And I think because I do anticipate so wireless power is merely the utility to provide, energy and a charging to the device, but the device technology are actually improving over time. So the device of a sensor is going to be using lower and lower power. If you really think about fundamental physical limit of how small of a power you can give to a sensor, is actually going to be a femtowatts. So I think the energy harvesting or wireless, RF forming of energy is sufficient to do one to many to implement in the space. So I'm actually very excited that the regulatory body first is clearance, and then also the IoT technology is getting more and more efficient. So there will be I think there will be a two market actually merge, and it will grow really fast in the next decade at least.
Well, thank you, Jeff. That was great insight. One final question for all of the speakers. What's your vision to your wireless power approach in the next 3 to 5 years? I'll start with, I'm going to go ladies first here, with Jen.
I think, the vision, I'm going to sound a bit like a broken record, but the vision for Ossia and wireless power is products in market. And that's going to range from Ossia products to other products coming from the players on this panel. We get better when wireless power is out there being used by consumers, by big corporations, enterprise, at home. That's the vision. I think we have made strong headway with regulatory bodies. We are all well equipped on the patent front. I think now is the time to get wireless power in the hands of the people.
Thanks, Jen. Good points. Charlie, how about you here?
Yeah, I think from our perspective, it's just continuing to execute on our plans and our roadmap. I think we've seen a big explosion of devices going into the market. We're going to see that continue to grow. I think we have a really good plan and strategy on how to continue to make inroads into different markets. Like I said, the technology is very much horizontal, and I think you're going to see it popping up not just in consumer electronics and IoT, but it's going to be in automotive and industrial and all over the place. And I think Jen mentioned, as more devices go into the market, more people are going to become familiar with the technology, and it's just going to kind of snowball from there.
Great. Jeff, over to you.
So I see the next 5 to 10 years, one thing for ETI is we are actually in part of this revolution of electrification. So we are actually trying to assist with the current infrastructure of electricity, and then we are trying to provide a new energy delivery system. This will actually greatly help the IoT industry to scale of a number of devices in the market, which will help the full industry of the wireless power. So that's what I see for the next 5-10 years.
Cesar, over to you for the last word here.
Definitely. What we have to do and what we have to achieve in the future, in the next 5 to 10 years, is really the deployment of RF wireless networks, being able to deploy. The problem is not a one-to-one problem. The problem is a one-to-many, and then multiply that by millions, right? So you have two issues. You have systems that have high data rates, basically being powered by, over time, high power devices. Today, we all talk about 1 watt. Sometimes we talk a little bit more, 5 watts, 10 watts. So as we go and increase, what's going to happen 5 to 10 years from now, we're not going to be talking about IoT, because IoT is now, we're going to talk in beyond IoT. And as we deploy higher power devices, you'll be able to support more and more higher power devices that will also require very sophisticated technologies and very sophisticated, perhaps new types of antennas and new types of digital signal processing that we haven't even thought of today. That's where I see it, and it's very similar to what happened in Wi-Fi and Bluetooth. It's all over again.
Now, back to the future, right? I mean, that's it's amazing what's going on. Well, I'm going to wrap us up now. I really want to thank our panelists for your time and your insights into how you're uniquely going after this market. and succeeding and getting wins in the market. Jen coined a good phrase. It's like devices in the market. That's going to show where the real promise for wireless power is. So I want to thank you guys for spending time with us today. I want to thank the audience for being here. I'd like to thank our sponsors. We have the WCA is a not-for-profit organization. We're all volunteers, and we bring you great events like today's event through generous contributions from our sponsors. So we certainly appreciate having them around. If you'd like to learn more about becoming a sponsor, you can reach out to me at the WCA, and I'm happy to talk to you about our sponsorship programs. I want to thank you for joining us again. Come back next month. We have a Back to the Future of Wireless. Marty Cooper will be joining us on May 19th, and we're going to talk about not really focused on the past. Marty's the guy who invented the cell phone at Motorola, and but we're going to talk about where things are headed. We've seen this migration from people using cell phones to talk to people using cell phones as more communicators and with text and data rather than voice. And so we're going to spend a little time talking about that. And we'll have a great little panel to address that. So on behalf of everyone who's part of the WCA and on behalf of all of our speakers, thank you for joining us today. And we'll look forward to seeing you at the next event.
Sure.
Bye all.
Most welcome. Bye-bye.
Thank you, everybody.
Thank you. Bye.
Thank you, everyone.
Yeah.
Bye.
Bye, guys.